All right, today we are going to go over a little more complicated wiring diagram and see if we can figure out how these circuits all work. We're just going to tackle them one at a time and see if we can make it make sense without having to refer to a theory of operation enough to do some basic circuit testing. So, today's vehicle is a 2012 Chevy Impala. We're looking at a headlight diagram. This is without the police package, so there's going to be some stuff missing on this diagram, but again, this is just a single page diagram. So you can see, let's go through and just make sure we know what all the components are. So you can see this shows the underhood fuse block, a not used wire, some other not used stuff, going up to a fuse that we're not going to worry about. Here we can see the left and right high beams, the parking brake switch, turn signal, multifunction switch, the ambient light sensor in the middle of the dash, the headlamp switch, the body control module, the instrument panel, the low beams here right in the middle of the diagram, and the fog lamps off to the right here. Excuse me. So, first place we want to start is, how does all this stuff get its power? Well, you can see the underhood fuse block has 4 relays that are fed on the feed, the control side, and the load side are all fed from the same feed that's hot at all times. So we know that the controls are fed with 12 volts all the time, and the load side of the relay is also fed here at pin 30 on each one of these. And then when the switch is closed, that allows power to go to whatever fuses the relay feeds and then out to the component. So, let's scroll down a little bit and see we have 1, 2, 3, 4 relay control wires. And if we follow those, they all go to the same place. They all go to the body control module. And you can see those are our relay controls, so those are the outputs from the body control module is actually going to ground each one of these to activate these relays. So how does the body control module know which relay to activate when? Well, then we're going to look for some inputs, right? So inputs to the body control module are going to be what? The headlamp switch, the ambient light sensor, the turn signal multifunction switch, the parking brake switch, and that's it, right? So we know we have the headlamp switch has got on, off, park, and fog lamps. So the fog lamp switch is obviously going to be the input for the body control module, so it knows that you want the fog lamps on. And you can see that this switch grounds the orange wire. So you can see when the switch is closed, this goes through here to ground, this G202. Well, how does the body control module know that this is grounded? There has to be some voltage coming out of here on this orange wire that gets pulled low. Again, it could be 5 volts, could be 12 volts, could be 10 volts, could be 8 volts, I don't know. But I do know, in order for the body control module to recognize that this is switched to ground, there has to be some voltage on this wire that has to get pulled low. And while we're here, we can look at our headlamp off switch wire. That is also a similar circuit, that it must get pulled low to ground in order for the body control module to know that the headlamp switch is off. And then you can see when it's turned to headlamps, and you can see the dotted lines again. So there's more wires here. So the park and the auto aren't just empty, but there's more wires here that would that don't apply to this diagram. So we're not too worried about those right now. but you can see when the headlamp white wire here is grounded, then it knows the headlamp switch is on. And again, there must be some voltage coming out of here that gets pulled low when this is switched to ground. That's the only way that's going to be able to work. So we know that that must be the case. So now we know how the headlamp switch gets shut off, we know how it gets turned on, and we know how the fog lamp switch works. So let's go down here and look at another input, the parking brake switch. Same thing, right? Switch to ground. So the parking brake switch input must have a voltage that comes out of it and then is pulled low when switched to ground. And if it is pulled low, then the body control module knows that the parking brake switch is applied. And let's look at the turn signal switch, or the multifunction switch, because we're not actually looking at left and right here. We're looking at high, low, and FTP. FTP is flash to pass. So we know that, again, this is a switch to ground. So we know we're going to be expecting voltage here when the switches are off, and then when they're switched on, or switched to high beam, or switched to flash to pass, these get grounded, and then the body control module knows that it's in flash to pass mode or just high beam mode. And you can see if both these are high, where the voltage is here and present, then it knows it's in low beam mode, because low beam mode isn't attached to anything. So if this purple wire has voltage on it, the body control module knows that you want the low beams on, not the high beams. If this voltage gets pulled low, then you know, or the body control module knows, that if this is pulled low, we're requesting high beams. That takes care of the inputs, other than the ambient light sensor, which again works very much the same way. The ambient light signal has a voltage that goes out, and then this is pulled to ground depending on the light source that lets it know how much light, or if there's no light being entering the vehicle, so it can decide whether to have the daytime running lights on or not. Because if it can't see any light, it's probably gonna have the daytime running lights on. Actually, I think these work backwards. I think the daytime running lights only come on if it sees sunlight. And then if you have it in the auto mode, if it doesn't see sunlight, it turns on the low beams. But again, we could verify all that by monitoring this and these inputs with a scan tool. Because this body control module does have a serial data line, and it may even have CAN bus data. But we're not even looking at that because we don't really care right now. But we do know that the body control module is on the network. We can communicate with this with a scan tool, so we can quickly verify all of our inputs with the scan tool hooked up to make sure that our inputs are doing what they're supposed to, and looking at our data PIDs on our body control module if we have an appropriate scan tool. Otherwise, the same thing, if you have a good scan tool, you may be able to use bidirectional controls to cycle on each one of these relays to verify that that's all working. So you can see how, now we know that we can control this with a scanner. We know these aren't just switches to relays, that there's a computer involved. And the same here for our fog lamp indicator and our high beam indicator, that communicates with the body control over the data line, or the computer data line. In this case, it looks like they're both low-speed GM serial data, or GM LAN. So let's go back up to our relays. So you can see the daytime running lamp relay. If this gets cycled on by the BCM, there's going to be, this switch will close. There'll be power on this fuse, which goes out of this wire and then into the daytime running lamp fuse here, which goes up to this splice and then feeds the left and right low beam fuses that power up the low beams. Now, if the daytime running light switch is off and just the low beams are on, it's going to feed out of here to the low beam fuses and then over to the headlamps and then to ground. And then you can see when the low beam relay is active, you'll actually have power on the daytime running lamp fuse here and here, but this will be open here, so there won't be any current flowing here or here, only on these two to turn on the low beams. So now the high beam circuit works about the same. When it's controlled on by the BCM, here on the tan and white wire gets grounded by the BCM. You can see it runs over there to pin 16, that's BCM, connector X4. And then when this switch gets activated, both of these fuses will have voltage on them, and then that allows current to flow down to the left and right high beam, and then current will flow through the headlamp to ground, allowing those lights to light. And same with the fog lamps, very similar, right? So you can see how they're using a set of simple circuits controlled by the BCM, and all of the inputs go to the BCM that allow all this control, which actually makes this really nice to diagnose, because you could hook up a scan tool to the BCM, verify all your inputs, verify all your outputs, and then go right to checking fuses. And if you command on a relay, and you know it's commanded on because you can see it in the scanner, and you don't have power here, you know you may have a faulty relay, you may have a faulty supply, or you may have a broken control wire. And chances are there are codes that will set if it doesn't sense the voltage here when it's not grounded. So if this wire is not grounded at the BCM, there will be 12 volts or battery voltage all the way through this wire, all the way here to the pin, all the way to the controller. And then once the BCM grounds it, there will be 0 volts here. And that's how the BCM can verify this relay circuit, or the integrity of that relay circuit. And again, you can see that there are other designations again with the circuit IDs here. This is an inline, X120 is an inline connector here. You can see again the dashed lines all the way around show that there are definitely more wires to this headlamp switch than what's being shown on this diagram. And you can see pretty much, I think, everything except for our components are going to have the dashed lines, because there's a lot going on. You know, there's a lot more wires going to the instrument cluster, a whole lot more wires going to the body control, and so on. So you can see how complex this gets quickly. This is still a single page diagram just to make the headlights work, and it gets pretty complex. They used 4 relays to be able to run the daytime running lamps, the low beams, the high beams, and the fog lamps. And then the relays are all controlled by the body control module, as we can see in the diagram. And we know all the inputs go to the body control module, and then the controller, or the logic controller in the body control module, is programmed to decide, based on the inputs, what's going to happen with the control at these relays. So I think that's probably all I'm going to cover today on this. Again, I just want to demonstrate the basics, understanding this is what a relay looks like, that's what a fuse looks like. These are LEDs here, and you can see the LED and this photo sensor look very similar. And you can see this has 2 arrows showing light going into it, where this has 2 arrows showing light going out of it. But they're both diodes in a way. We're not going to get too in-depth there because I don't want to confuse you. We're covering wiring diagrams. That's the most important thing that I want to cover in this series, is just how to decide where's the best place to test then. So if we have a pair of headlight bulbs that do not work, the best place to test might be the body control module. If we have a scanner hooked up, might be a good idea to see if we're getting our high beam switch is telling it to turn on. Are we getting our indicator on our dash? Is our relay getting active? do we have a code in the BCM that says that we have an open on this wire and it's not seeing 12 volts when the relay is not active? Do we have some blown fuses? However, we're going to check these fuses without the relay being active. How do we even know that? Well, we have to look at the wiring diagram. So we know if we're not getting power on these two fuses and our high beam indicator is on, then the BCM probably knows that everything else is working and maybe our relay isn't working. Or maybe our high beam indicator isn't on and we need to look at the data in the body control module to see if our inputs are there, see if there's any codes related to the high beam circuit, and see if we can manually turn this relay on and then monitor the voltage at the high beam fuses. Or knowing this relay isn't connected, we could take a jumper and jumper at these fuses to see if the headlights come on. So there's a bunch of different ways we can tackle this, but part of looking at the diagram is figuring out how it all works as a whole assembly, as a whole system, and then deciding where is the easiest, most logical place to test to get the most information with the least amount of testing. And in this case, since we're dealing with a module, in my opinion, if I have a module that I can communicate with, I'm going to hook a scanner to it and take a look. I want to see what I can see for inputs and outputs. I want to see if I can actuate this relay and turn it on with the scanner. I want to see if there's any codes in there, because there may be a code in here in the body control that's telling me that this wire is open. It's not seeing 12 volts here when it's not grounded. And if this wire isn't grounded, there'll be 12 volts right here that it's monitoring. It may be monitoring for circuit integrity. So if this wire is open, it might have a code in there telling me that it's not seeing voltage on that wire, and we know that maybe we have a bad connection here at X2, C6, or maybe this is open, or maybe the relay is faulty in general. So, there's a lot of information on these diagrams, but the most important thing to me when I'm looking at these diagrams is, how does the system work? Do I understand how the system works? Can I get enough information from the diagram to decide that I'm confident I know how the system works? Can I find a convenient place to test that's going to be an efficient use of my time and get all of the information that I need to finish this diagnosis? Whether, we have a pair of headlamps not working, low beams not working, fog lights. Either way, before we go chasing the problem, I'm going to glance at this diagram so I have a good idea how everything works. Because you might be thrown off if you just take a test light and go right to these fuses and go, well, I don't have power on any of these fuses. And if I don't have a diagram in front of me, how do I know that all of these fuses are relay controlled? I wouldn't necessarily. So then you might be confused. You check all these and you go, well, I don't have any fuses on any of these. Do I have a bad fuse box? Do I have a bad connection somewhere? You could really confuse yourself if you don't understand how a system works and the logic behind it, so that way you can tackle the system as a system, not just, well, this is the problem, let's figure out what's going on. Let's look at the system, let's verify we know how it works, and then find a convenient place that we can gather the most amount of information with the least amount of work to decide what the next step is in our diagnostic process. But this is always a great starting point, and if you get good at reading these wiring diagrams, you can save a whole lot of reading at the theory and operation stage of figuring out how these work, because there's only so many ways to make any bit of electricity work. There's only so many tactics, so many tricks, so many ways to design a circuit to be effective and reliable. And the more you read them, the more you go through them, the more you'll start to see really common, really repeatable situations. Just like these switches. All these switches are pulling a voltage low to indicate switch position. So all these switches are switching a wire to ground to pull the voltage low to indicate to the computer what position the switch is in. And you can see they repeat that for multiple inputs, or all using the same engineering tactic to come up with that. And that's not just one. These switches can work in many different ways, including resistance to ground, which is going to pull the voltage to a specified voltage instead of low. Instead of pulling it to 0 volts, it might pull it from 5 to 8 volts, or from 12 to 8 volts, or from 8 volts to 4 volts, in order to determine switch position. But again, we don't know that unless we refer to the wiring diagrams and do our best to understand that. And sometimes the wiring diagrams won't be as much help, and we'll have to read the theory and operation in order to figure it out. But otherwise, you can see there's some inline connectors here, and all these are searchable. So if you have your service information pulled up, you can search this connector, look for a pinout. You can see where it'll go from yellow on one side to green on the other. And same here. You can see where it'll go from one to one side, colored to the other. And that'll be in the pinout diagrams. And just like this junction here, there will be a location associated with this junction, or with these grounds. There will be a location associated with these grounds. They're not always listed on the diagram. So you can see, now that we understand how this works, I would confidently turn on the headlights, go to these fuses, see if I have power at these fuses. If I have power at these fuses, next place I'm going is right to the bulbs. I might have 2 burnt out bulbs if both these fuses have power and light a test light. It might be a simple fact if I have 2 high beam bulbs burnt out. I have seen that quite a few times. It does happen. And the same with the low beams. If I have power on both these, I'm not going to go check my inputs. I'm not going to hook a scan tool up, because I know, now that I've looked at the diagram, if I have power here, either my daytime running lamp relay or my low beam relay is active, feeding these 2 fuses. And I know, even if I don't know which one of these is active, I can figure it out really quickly by pulling the daytime running lamp 2 fuse. If I pull this fuse and I don't have power to my low beams anymore, then I know it was getting fed from over here. If I pull this fuse and I still have power, I know it's getting fed from here. So you can use these little tactics, same with the fog lights too. If this relay is active, I will have power here that will light a test light. So if I turn on the fog lamp switch, I expect this to have power. If it does, I'm going to the bulbs. If it doesn't, I know I may have a control problem, and I need to go to my body control module and verify my input and verify that it's trying to activate that output. And if not, maybe I manually activate it with the scanner, or I would check my inputs and see what's stopping that from coming on. One thing that may stop the fog lamps from coming on is the high beam switch. If it's stuck on high beam, and for some weird reason my high beam indicator is burnt out or not working, it might be on high beams. My fog lamps won't work when the high beams are on. So just, little tips and tricks on, you have to understand how all this works. And then once you do understand how it works, it becomes a lot easier to decide what the next step is. Where am I going from here? Where's a good place to start? Well, the fuses are easy to get to. I can turn on my inputs without having a scanner hooked up. If I'm doing a pre-scan and I know I'm dealing with a light issue, I may glance at the body control module, see if it has any code set in it. Maybe just check my inputs quickly while I have the scanner hooked up, because I can verify my inputs, whether I have codes or not, and maybe my outputs in less than 10 minutes before I even get the car pulled into the bay, or just after I get the car pulled into the bay. And then I can go, well, everything looks really good there. I'm going to go check my fuses with the switch on, because I looked at my diagram and I know those fuses won't have power unless the relays are active. So I need to know which relay I would expect to be active and then check the appropriate fuses. I hope that all makes sense. I'm going to cut this off here. So I hope all that makes sense. I hope you learned something. I hope this makes your next diagnostic dilemma easier, more efficient, a little more straightforward. And you can see how complicated these wiring diagrams can be, is this is still just one page. And I think on the next video, we will go ahead and check out a 2-page diagram that's a little bit more complex than this and see what all we can get figured out with that one. So thanks for watching. If you like what you see, comment, let me know. Let me know what you'd like to see, and like and subscribe and all that stuff. Again, thanks for watching.